In this chapter, we'll look at some of the more complicated examples of calculating area under graphs.
The graph shows the velocity of a car over a 10-second period. It shows, for instance, that the velocity of the car was 0 meters per second at 0 seconds and rose steadily to 8 meters per second over the following 4 seconds. Between 4 seconds and 7 seconds, the car travelled at a constant velocity of 8 meters per second. Considering the time between 4 and 7 seconds, if we wanted to know the distance travelled by the car, we could use the formula distance equals velocity multiplied by time. You can see which formula to use easily on a distance-time triangle.
Using this formula tells us that over this period, the car travels 3 times by 8, that's 24 meters. We know that the distance will be given in meters because the time is measured in seconds and the velocity in meters per second. We multiply time and velocity together, so we multiply seconds by meters per second, and this gives meters. Notice now that if you multiply 3 by 8, you are finding the area under the graph for the period between 4 seconds and 7 seconds. The graph forms a rectangle here, and the area of a rectangle is given by length times by width.
In fact, we can find the distance travelled in any period by finding the area under the graph for this interval. Let's use the graph to find the distance travelled during the whole 10 seconds. The graph forms a trapezium, with parallel horizontal lines of length 3 and 10 and with height 8. We find the area of a trapezium by adding the lengths of the parallel sides, dividing this by 2, then multiplying by the perpendicular height. This is the perpendicular distance between the 2 parallel sides.
Let's apply the formula. 10 added to 3 gives 13. Multiplying by 1/2 is the same as dividing by 2, so dividing by 2 gives us 6.5. Now multiply by 8, the height, which gives 52. We multiplied seconds by meters per second, so again, the distance is measured in meters. We've learned that the total distance travelled is 52 meters. Make sure to remember that finding the area under a velocity time graph gives the distance travelled.
Finding the area under certain other graphs can also give significant information. Let's think about a force extension graph, which shows the increase in the length of a spring when a given force acts downwards on it. The area under the graph now tells us the amount of energy stored in the spring as the extension changes. Consider the area under the graph between an extension of 0.08 and 0.16 meters. The shape of the space under the graph between these extensions is a trapezium with vertical parallel sides of lengths 4 newtons and 8 newtons. The perpendicular distance between these parallel sides is 0.08 meters. Using the formula for the area of a trapezium, area equals the sum of A and B multiplied by 1/2 and multiplied by the height, we find that the area under the graph is 0.48.
Since we are multiplying a measurement in newtons by a measurement in meters, the result will be measured in Newton meters. The increase in energy stored by the spring is 0.48 Newton meters.